The average of 60 does not best represent the data. My reason is that the mode, which is equal to 50, or the median, which is also equal to 50, better represents the data than the average, which is equal to 60. Why? Because the median captures 80% of the data with no error. With this, it is meant that 80% of the data matches the median exactly. But for the average, if you do the calculations, you will see that the average of 60 does not match any of the data points exactly, and it has error for each data point. Moreover, we can look at how the errors differentiate. What are the differences between the error you get on the data set at each point for the median, the average, and what is the difference with the difference of the error that you get from the data points generated by the average. So we will be looking at two sets. We'll be looking at a set which consists of the error from the average of each point of our original data set, which is 50, 50, 50, 50, and 100. So our first set, call it AEM, which is the average of the error data set generated from the median. We claim that the average of the errors of the data set generated from the median is less than the average of the errors of the data set generated from the average of 60. Let's look at it in terms of a set. So here we had our original set, so we're subtracting our median from it. So we took our original data point of 50, subtracted 50 from it, squared it, and took the square root. This is to take the distance. So how far the median was from the point. So the error. So I did it for the first point of 50, the second point of 50, the third point of 50, the fourth point of 50, and the fifth point of 100. Then you get a set which is equal to, with data points of 0, 0, 0, 0, and 50. For the second data set, AEM, which is the average errors AEAV, which is the average errors generated by the average, I just find what is the distance from the average of each data point of my original data set. So I took 50 minus 60, squared it, and took the square root just to find the distance. So 50 minus 60, square root. 50 minus 60, squared, square root. 50 minus 60, squared, square root. 50 minus 60, squared, square root. And 100 minus 60, squared, square root. Then I ended up with a set of points of 10, 10, 10, 10, and 40. Then I find the average of the first set, which is the errors of the data set generated from the median. And then I find the average of my second data set, which is the errors of the data set generated from the average. So I just find the average by adding all of my data points and dividing them by the number of data points which I had. So my average or mean for the average error data set generated by the median is 0 plus 0 plus 0 plus 0 plus 50. Then I divide that by 5, which gets me 10. My average or mean of the data set generated by the errors from the average from my original data set is 10 plus 10 plus 10 plus 10 plus 40, which gets me 80, and then I divide that by 5, which is equal to 16. So you see that on average, my error for the median is 10 from each data point. And on average, my error for each data point is 16 for the average. So the median of 10 has a smaller error than the average of 16. And this is why I claim that the median better represents the data set compared to the average.